We are now going to look at modules 9 and 10 of the Math 137 online class. I'm going to look at these two modules together. Module 9, I believe, is actually law of sines, and module 10 is law of cosines, but I like to teach it all the same, or all together. Now this is we're taking a pretty big departure from the kind of stuff we've been doing so far in this trig class. We've been learning about unit circle and angles and radians and trig identities and trig formulas and all kinds of stuff like that. This is going to be a fairly major departure, and maybe some of you will find it as a nice break. First of all, law of sines and law of cosines, we're talking about working with triangles. So right now, we're taking a break from unit circle, and some of you might be happy about this. All the problems in these two modules, when we discuss angles, we're going to strictly talk about angles measured in degrees. So we're talking about triangles, and when we talk about the angles of these triangles, we're going to express them in degrees. Now let me draw just a standard, and these are not right triangles. You could have a right triangle. Most of them are just random triangles. So here is sort of a standard notation that you're going to find in your book. First of all, of course, three angles. If we use capital letters, that indicates the angle. So capital A is the angle of this angle, B is the angle of this one, C. Now what we do also, there are really 6 parts to this triangle. There are 3 angles, and then we have 3 sides. So the 3 angles, we simply label capital A, B, and C. Then what they like to do is, for the sides, the side opposite angle B, the length of that side is going to be called small b. The side opposite angle A is little a. Then the side opposite angle C is little c. Now the C's are the hardest because sometimes the only difference between capital C and little c is the size. At least with the B's and the A's, they're written sort of differently. So anyways, here's a key initial point. The triangles we're going to work with have 6 parts, right? They each have 3 angles and 3 sides. And one of the key things we're going to realize is, in all the problems we're going to start working on, here's an important point. If we are given 3 parts of a triangle, we can figure out the remaining 3 parts. Now there's one exception to this, which I'll talk about in a minute, but it's true for almost all triangles. In other words, if you're given, there are 6 parts of a triangle, if you're given 3 pieces of information, say you're given 2 angles and the length of one side, if you're given those 3 parts, we can use these laws to figure out the other parts of the triangle. Say you're given the lengths of the three sides of a triangle. We can use that information, apply these laws, and figure out the three angles. So you're going to see in all the examples that we're going to start working through, we're going to be given three parts of the triangle, three pieces of information about the triangle. And based upon that, we're going to go use these laws to determine the remaining three parts of the triangle. Now, before we actually apply these laws, there's one important fact which you oftentimes will use. And hopefully you know this. I'm going to put a remember here. Remember the sum of the three angles in a triangle equals 180 degrees. Hopefully you remember that. If you have a triangle, if you add the three angles together, they always equal 180. So if we call capital A, this is the measure of angle A, plus capital B, plus capital C. This becomes helpful because oftentimes you will get to the point where you know two of the angles of your triangle, and then this is very easy to get the third angle. So this is something that we're going to use over and over again. It's very helpful. Now let me go ahead, before we actually start working problems, let me just write down the law of sines and then the law of cosines. First, the law of sines. What it is, you take the sine, so this is a trig function, and almost all the time in this section we're not going to memorize or remember these signs in our head. We're going to use our calculator. The sine of angle A divided by the length of angle A. So you take the sine of an angle and divide it by the length of the side opposite that angle. Turns out that equals the sine of angle B divided by the length of side B. So here we have an equation that relates sort of the A's and the B's, both the angles and the sides. But we don't stop there. We can actually have another expression where we have the sine of C over side C. So it's like we have three parts to this, and we compare up any two parts we want. For some problems, we're going to use sine A over A equals sine B over B. The next problem, based upon the information we're given, we want to use sine B over B equals sine C over C. Maybe the next problem, we're given information about A and C, and we want to use sine A over A equals sine C over C. So there are three parts here, but anytime you're going to use the law of sines, of course, you have to choose two of these expressions to set equal to each other. So it's sort of like three parts of the law of sines. Now the law of cosines also has three parts, but there are actually three different equations or formulas. Now you'll see they follow a pattern. Let's start out with side A squared equals side B squared plus side C squared minus 2BC times the cosine of A. So what's going on here? First of all, you notice this formula has all three sides in it. Here's A, B, and C. And then also one angle, cosine A. Whatever is out here, we started with A squared. We have a bunch of stuff, cosine A. I have another law of cosines. I can put the B squared out here, and then I end up having A squared plus C squared minus 2AC times, on here, since the B squared's over here, when we do the cosine, it's the cosine of B. So hopefully you can see a pattern. You choose a side over here, the other two sides are here, they get multiplied, and the cosine of that angle. We can also do one for C squared. Hopefully you'd think, well, that means A squared plus B squared minus 2AB. What's the cosine of going to be? Cosine of angle C. So we have three different laws of cosines. And whichever one of these you use will depend upon the information you've been given in the problem. All right. So let's start looking at all the different scenarios. Once again, we're dealing with triangles. Three angles, three sides. Because what's going to happen is the kind of problem you're given and the kind of information you're given will dictate what equation and how you solve it. In other words, a certain problem, you're going to use law of sine. But the next problem requires you to use law of cosines. Occasionally, sometimes you have a choice. Maybe you can use law of sines or law of cosines. It's up to you. So let's go through all the specific scenarios. And there are really only four, when you think about it, four kinds of triangles we're going to look at. By kinds of triangles, what I mean is the initial information they give us. In other words, remember, they're going to give us three pieces of information about a triangle, and then we're going to go and figure out the remaining three parts of the triangle. So for instance, and let me go back. I said way back at the beginning, if we're given three parts of the triangle, either sides or angles, three parts, we can figure out the remaining three parts. I wrote that down, although I did say, well, there is one exception. Let's just take a minute and look at the exception. If you're given, say you're given three angles. Say angle A is 40 degrees, angle B is 50 degrees. What would angle C have to be? 90 degrees. So you're given the three angles of a triangle, and then they say, figure out the other parts of the triangle. Here, since we know the three angles, basically we'd be asked to figure out the lengths of the three sides. Well, as it turns out, if you're given three angles, we're not able to come up with an answer because there are many triangles that can have these angles, and they all have different lengths of sides. I mean, this is not good. Let me just, so here, say here's a triangle, angle, angle, angle. And of course this is little a, little b, little c. Now what if I do another triangle, totally symmetrical, which means it looks just like it, except it's just expanded a little bit. You know what? This triangle, they have the same angles. But obviously, this side and this side are very different. So if I'm given 3 angles, which triangle am I supposed to use? I don't know. And that's why, just so you know, you will not be given problems with 3 angles because we can't determine the 3 sides. We don't know. There's an infinite number of possibilities. So just so you know, this is the exception to what I said earlier. I said earlier, if we're given 3 parts of the triangle, we can figure out everything else. That's true, except for this situation. So let's actually look at the cases where we can actually figure out the triangles. The first one, I'm going to start when they give you a problem, they give you 2 of the angles and 1 side. So if you're given a problem and they say, here's a triangle, and here's angle A, and here's angle B, and then they give you a side, for this, we're going to use law of sines. As a matter of fact, what you're going to see in this lesson is you don't really have to necessarily memorize, for the most part, which law to use. Usually, there's only one possibility. In other words, let's do an example problem. How about we're given this? Now I'm going to draw a triangle. Now this triangle is not going to be perfect because I'm going to give you some of the angles and the sides. So it might not be the correct proportion, but I just want to be able to see. So they say, let's say this is 45-degree angle here. Let's say this is a 95-degree angle. The length of this side is 5. We'll call this angle A, which means this is side A. And we'll say that 45 degrees is angle B. So that's side B. So what are we given? We're given 2 angles, 45 degree, 95 degree, and 1 of the sides. So therefore, what do I have to figure out? I have to figure out the length of side A, the length of side B, and the angle A. Let's say for some reason you're given this on the test and you're nervous and you start to forget and you think, oh no, should I use law of sines or law of cosines? What if I tried to use law of cosines? Which one of these 3 would I use? What do I have? I'm given 1 side and 2 angles. But you know what here? If you tried any one of these 3 equations, none of them would work. You don't have enough information. You can sort of see with law of cosines, you really need, it involves the 3 sides and 1 angle. So if you tried to use law of cosines, it wouldn't work. So if you forget which one it is, it's got to be law of sines. So it's figured out. So what do we know? Let's write it down. So we know angle B is 45 degrees. This must be C. So we know angle C is 95 degrees. And then side C is 5. So we know angle B, angle C, and side C. We need to find these 3 things. Law of sines, look at here. I've got B's and C's. Law of sines would say the sine of angle B over side B equals the sine of angle C over side C. Now actually, I probably shouldn't have done this, and I always forget this. You know what you should do right away actually as a habit, and I forgot to do it? If you're given a triangle and you're given 2 angles, what should you do right away? The easiest thing to do? Easiest thing to do is to figure out the 3rd angle, right? Because 3 angles of the triangle must equal 180 degrees, right? So angle A 45 plus 95 is 140, so we're going to subtract 140 degrees. So I know right away angle A is 40 degrees. So I forgot that. But anytime you're given a triangle and you're given two angles, first thing, go ahead, determine your third angle. All right. Now I can go back here, and since I was given angle B and angle C and side C, I can use this law of sines because I know angle B, I know angle C, I know side C. That leaves me with one variable, side B. Now to solve this, some of you remember how to cross multiply. That makes this easy. So you would have B times sine C equals C times sine B. If I want to solve for B, I can have C times sine B over sine C. The length of C is 5. The sine of B, angle B is 45, so sine 45 degrees. Sine of C, C is 95 degrees. So here's the calculation. Grab your calculator, make sure you're in degrees. So 45 sine divided by 95 sine times 5. Let me round it to 2 digits. I have 3.549, so we'll call it 3.55. So now I've determined B is 3.55. The only thing left is to determine the length of side A. What am I going to do? I'm going to use the law of sines again, and I have a choice now. I can either pair A up with B or C. Then we just paired up with C since they're nice numbers here. So I'm going to say the sine of angle B over little b equals the sine of angle C over little c. Let me just go and plug in everything I know here. I know angle B is 45 degrees, so the sine of 45 degrees, I do know. I know the length of, I messed up. Wow. I'm wanting to find A. Wow, even got confused myself. So let's link up A and C. Sine A over A equals sine C over C. So sine A, we know A is 40 degrees over A. Sine C, C is 95 degrees. Now the length of C is 5. So if we cross multiply and do the algebra, you end up with A equals 5 times sine of 40 degrees over sine negative 5 degrees. So 40 sine divided by 95 sine equals times 5. Round off 3.23. And now we figured out the 3 remaining parts. So here we go. First example, probably the easiest. You're given a triangle. You're given 2 angles and 1 side. You just apply the law of cosines. First of all, you can realize that the three angles have to equal 180, and then you apply the law of sines, and you can figure everything out. Let me pause this now, and then the next video we'll start looking at the next kind of triangle we're going to look at.